1 and j and I and j minus 1. That gives us these two. So what happens if I send in 1, 1, and I get 0, 1? So 0, 1 is encoded here. Well, if it's 0, 1, okay, it's the same as t of 0, j minus 1, and this gap that I've decided, right? This is the gap function that I said would be used. And then t of I minus 1 j, if j ends up being 0, then this is the gap function I'm going to use, and that gap function is encoded here. Okay. The reason why I keep doing this I minus 1, j minus 1 for ij 0 is that you could potentially the way that you would normally do this is set it all to 0, right? You would say, okay, well, if something doesn't have a match, if you look at the LCS version, right, it's t of I equals 0, t of I 0 is equal to 0 for 1 to n, and same thing here. But you can't do that here because I don't know what this value is. I have no indication of saying that this is 0. If I was to say that this is equal to 0, I will have concluded that this matching of a gap is a 0 value function, but the function returns 0. But I don't know that. I can't assume that. Therefore, I always have to add it to whatever this previous number was. And what this means is that if this previous thing was also 0, because the gap function is 0, it would be carried forward here. If this previous function of a gap function, the checking against a gap, has some value to it, it would continuously add that value going forward as I create more and more gaps. Okay, and that is why this works. Okay, so the runtime and analysis, number of subproblems. I have 2 dimensions here, I and j. This is O of n. This is O of m. So that gives me this runtime. And then this right here, the comparison of a function, we're assuming the function is O on runtime. I think it tells us that, no? Or does it? Well, it's a matrix lookup, so it's O of 1. And then these are O of 1. A look back of a single value is O of 1. So this entire thing concludes to be O of 1. So the work to be done at each subproblem is O of 1 times the O of n times m. Subproblems gives us a overall O of n times m runtime. And then how is the return value extracted? Well, we're carrying forward. This is an LCS type problem, edit distance problem. We're carrying forward our best solution at all times. So it's the final value in our table. So it's O of n m. And therefore, it is a O of 1 runtime to access that value. All right, that is 6.26. Questions, Stephen?
Yeah, no, I was just gonna say, if I know this, you said this is the last question, right? That you're gonna go over.
Yes.
Yes. I was gonna say, if this is the end, I was gonna ask if we could, like at the end afterwards, if I may, just quickly get back to my question about the 6.4, because actually it would take like 2 seconds to just talk about it. Actually, at the end, if I may, if we can.
Yeah. I'll allow that. Any other questions?
Thank you.
All right. Let's go back to 6.4 and see what your question is.
Wow, that was quick.
Right.
It was really more of a question just about memoization, I think, because like basically my algorithm is actually the exact same thing as your algorithm, except basically like if you have like hello world, for example, and you're gonna just loop through every j, like if you split on h and hello world, like you don't really have to make that split because h obviously is not a word, so you don't have to do that. And same with he and then low world, like you don't really have to check that one at all, so you can just skip, because well actually he is a word, but for argument's sake, say he wasn't a word. You would just say he isn't a word, so just we don't have to check, just we would just say that's not a word either. So then we really the only one we really have to check at all was just the index of hello and world. So we have to check if all of hello world was a word or if just world was a word. But that that like I did that by just like keeping like an index of the valid indexes, and so that was basically my implementation. I'm just wondering if
so you keep track of all your valid indexes, which is fine if that's what you want to do. But how do you how do you scan across all those indexes to know if the indexes you have can be added together to make full words, right? Like
Because if you
like
yeah,
the
sorry.
idea is that, like, yes, obviously H is not a word. Obviously he is a word. Obviously HEL is not a word. Obviously HEL is a word. But you don't know that until you check it, right? Like, how do you know H is not a word? Well, you check to see if H is not a word.
Well,
How do you know that H?
what's up? Sorry.
Yeah.
Well, it was already checked when I checked if H was a word. So on the very iteration, we checked if H was a word. We said, oh, is this valid substring of the entire string? Is this going to be a valid solution to the problem? We say, well, no, H is not a word, so no. So we don't put that into the valid word list. And we check HE. And we say, well, let's just say the dictionary just says hello world for argument's sake. So we check HE and we say, no, it's not a word. So now we already know that, like, so now we go back and we get all the way to hello world, and we check the J for we're looping through our J's. We don't have to check H again because we already know that, yeah, sure, hello world might be a word, but the whole thing won't be a word because H isn't a word. So we don't have to check that. So we just say H isn't a word, so we just it.
That's
so just
what we're doing, right? So after we append the letter D, right?
Yeah.
We now have to work backwards, right? Forget this for a second. We now have to work backwards and say, okay, what is the last letter that D together with everything in between makes a word? Is it L? No. Is it R? No. Is it O? No. Is it W? Yes. So now you know world is a word, right?
Yes, you know that. Yeah, you well, now you do. Yeah.
Now,
Exactly.
hold on. Now your question is, well, we kept track of the indices of everything that was valid, right? So what I track with T of J minus 1 is everything below 0, before O, proper words. Yes. I don't go all the way back to H. All I did was go back to O and say, is that a word? And I immediately say yes, and I'm done. I think that's what you're saying, but it's already encoded in this way.
Right, but there's repeat work with the if you're looping through all J's, like, you already know that H isn't a word, so you don't have to check that again. So if you loop through all the J's, like, you're looping through H, HE, HEL, HEL, L, and then HELOW. It's like you don't really have to check all that stuff. You can just check, is hello world all of it all word, or is just hello and then word? Is that a valid a set of words? And so you just check those two. That's really all you have to check for the thing. So it's just a faster
No,
thing.
because you're assuming that if this is a word,
Exactly.
right, and that's the most recent word, that everything else is all that needs to be checked, right? But it could be possible that how is a word and O world is a word, but
True.
world itself is not a word, right? So you always have to see any combination of this.
Yeah, true. But if hell was a word, then it would have been in valid indexes array, and so we would check hell if that was a word. But we would just not check words that aren't words. We would say H. We know H isn't a word, so we don't need to check H and LO world.
Right, but how do you know H is not a word?
Because it's not in their valid indexes array. You know what I mean?
So what you're saying is that instead of storing an array of where the valid words are and where the things are not words, you would just keep a list instead. That's all you're saying, right? You would just keep a list.
Well, yeah, because it would allow. Yeah, you just keep a list of the valid index.
So okay.
Words,
So
and then
when you're coding, hold on. When you're coding, and that absolutely works, and you should do that. Actually, if you're coding, you should just create a list. There's no reason to create an array. But there's a couple of things to consider. One, creating a list and appending to a list has a cost. In computer science and software engineering, when the list gets reallocated, when you expand upon a list that has hit its ratio, its load factor, that expansion has a cost. So it's not always that the list is just going to be with an array, because you know exactly how big your array needs to be. That single allocation does not get reallocated. It doesn't get copied. So it's up for debate whether coding it with a list or coding it with an array is faster. The second thing is, in terms of doing this, and you're doing just an overall runtime, it's going to be all of n squared no matter what. It doesn't really matter which way you do it. The list itself, even if it does save you runtime, it doesn't save you runtime in the big O notation sort of way.
True, but in the best case, it's O of n, and And if
We
you
don't
use,
do best case in this. We don't use best case in this class.
yeah,
We only use worst case.
yeah, that's true. But if you use your table,
Yeah.
then it would be the same amount of space too, though. If you use the table as your array or list or whatever. Yeah, but no, the question really is that like this is just an optimization. Like it does make it go faster.
Well, my argument is that one, it doesn't matter for the sake of the class whether it's faster or not, because all we care about is worst case. And second of all, like I said, when you're coding this, it is actually unknown. It's unless you actually go and track it. It's actually unknown to me which would be faster. Your list reallocation of the list and copying over might actually be slower than a known size array to be clear at the very beginning. That's just like a software engineering aspect of it.
I heard you saying, but if you just use your table, wouldn't it be the same amount of space either way? So wouldn't it be the same? And just...
Yes, but allocating a set space and then never reallocating, never copying that to a larger allocation of memory is a one-time runtime that you spend, right? When you reallocate memory and you have to copy things, there is a cost to it in software engineering.
Yeah, but aren't you already building a table? So like you're just building a table anyway. So
you should really look into the runtimes of appending to a list and making the list resize. I'm telling you right now, it's not a set runtime. It has a cost.
No, I know it's not OF1. I know there's a cost to appending to a list, but I'm saying you're already building the table. But yeah, you're already building the table. But yeah.
That's not how list allocation works. But again, it doesn't really matter. It doesn't really matter.
No, but my question is about memoization though. I'm saying is that not allowed because you're kind of storing it and like kind of checking the thing? Like that's really my question. I'm really asking about like, because I know memorizations. They said like it's not allowed in the syllabus or whatever. Somewhere they said it. I don't know.
It's not the same thing as memoization. Whether it's allowed or not, I actually don't know. I don't think you have access. I mean, I don't think you have access to a list in these problems because we're looking for a table entry. So I don't think you should do it. And like I said, it doesn't actually help with anything. So
you couldn't iterate over your own table like within your solution. I mean, that's really the question.
You can. That's exactly what's going on, right? Right here, you're iterating over the table.
Yeah, exactly. It's just faster. No, I hear you saying it's a good solution. It's definitely faster. It is more optimal because it's the same amount of space either way. So it's actually less space. So yeah, I'm just saying.
Okay. Do we have any other questions?
For sure, it is. You can look at the solution. Yeah, definitely. Yeah.
Okay. So yeah, if there's no more questions, I will be back next week covering Divide and Conquer.
Okay, thank you, by the way, for answering the question.
Wait, I had a quick question. Can I ask or no?
Yep.
Yeah, Joe, it's just one more question, and then I'll let you be. For the basically,
sure.
Is it okay if we can use a second table just to assist a second table to as a form of assistance for our recurrence? So, for example, like, if we
yes,
I have a table for my home. Sorry.
Yeah, the answer is yes. You can have multiple tables if you needed. I mean, a 2D table is really just n tables, right? Like you can have two tables if you need to track something different. You can also have a table track multiple inputs. Like you could have a 2D table that's O of n by 2, right? And that O of n by 2 table tracks two different things across n entries. That's okay. Or you can do a T table and an S table. That's also fine. Either way, you're allowed.
Okay, thanks.
Yep. All right. Enjoy the rest of your long weekend, everybody.
Thank you.
You too. Thank you.
Thank you very much.